Hey, in this video we're finding the area in the first quadrant that's bounded and enclosed by the graph of y equals sine x, y equals 1, and the y-axis. So this purple shaded region right in here. We're first going to do it by integrating with respect to x, which means our rectangles will be going in this direction and our width will be parallel to the x-axis. And next we will be doing it with respect to y. So our rectangles will be going in this direction and our width will be in the direction of the y-axis. So let's get started. Alright, so to do this, what I'm going to do is I'm going to find the area of this large rectangle where the height is 1 and the width is pi over 2. So that's 1 times pi over 2 for that big rectangle, minus the integral of sine x. You see this here, and when I subtract these I'll be left with just this purple region here. So minus the integral from 0 to pi over 2 of sine x dx. So that's pi over 2 minus the integral of sine is minus cosine, so that's minus times a minus, so plus cosine from 0 to pi over 2. Okay, equals pi over 2, and then cosine of pi over 2 is 0, so that's plus 0, minus cosine of 0, which is 1. So our answer here will be pi over 2 minus 1. Alright, so that's with respect to x. Now let's try it with respect to y. What we first have to do is make this function equal to x, not equal to y. So right now it's y equals sine x. Solve for x, we get x equals sine inverse of y. Alright, and also remember we're integrating along the y-axis. Our width is the y, so that's 0 to 1 will be the widths of our infinitely many rectangles. So 0 to 1 of sine inverse of y dy. Okay, maybe you've done this problem before. This integral requires integration by parts. So integration by parts says we will let u equals to sine inverse of y, which means du will be 1 over root 1 minus y squared dy. dv will let equal to 1 dy, which means v is equal to y. Okay, use the check mark. So our formula is uv minus the integral of v du. If you do it that way, it'll always make a check mark. So uv, so that's y sine inverse of y from 0 to 1 minus the integral of v du, which is y over root 1 minus y squared dy from 0 to 1. Now y sine inverse of y minus, now what we have here is we have a root in the denominator, which means it's to the power, if I brought it up, it was to the power of minus half. So I know this will be here. Add 1, so it's to the 1/2. And if I take the derivative of this inside piece, I get 2y. Well, I don't have a 2y. I have a 1y. Actually, it's a minus here. I have a 1y. So when I take the derivative of this, I'll get minus 2y. And I have a 1y, which is positive. So that minus I need to counteract with this. And the 2 that comes out and the half that comes down will cancel. So this looks like it's the integral to me. Make sure you take the derivative. If you don't trust me, take the derivative just to make sure. So that's 0 to 1. Okay, so now let's plug in 1. So that's 1 sine inverse of 1 plus, plug in 1 here, we're left with 0. So that's plus 0 minus, plug in 0, that whole thing is gone, and plug in 0 here, we have 1. Alright, sine inverse of 1. So when is sine 1? That's what that question is saying. Sine is 1 at pi over 2, and everything else I should be left with a minus 1, which you can see is the exact same answers we got before. Clearly, taking it with respect to y is much more difficult. However, that's not always the case.